Hi everybody and welcome to my video about Powershell and DnSpy tricks in .NET reversing. We will be reversing malware called AgentTesla. You can see the MD5 hash is here and other related information, basically something like GOT, is on my GitHub page. You can get to this page like if you visit my GitHub. You can check the repo malware analysis and reverse engineering, and the last one is basically PowerShell and DnSpy tricks in .NET reversing. You can see some of you probably know me from Twitter, and basically I spent like 2 weeks with sharing some tips about .NET reversing, like dynamic invocation of methods from PowerShell and other stuffs, which I think are very useful. I shared via some tweets and many other things from .NET internals, so I hope you like it. And basically this video was created because I want to summarize it in some video and basically analyze something which is very known, and you probably have to deal with it sometime. Basically all things I will be covering here you are also able to implement these things, and you are also able to do these things in any kind of .NET reversing. So I hope this will really help you with stuffs like deobfuscation, in-memory patching, and other things I will explain later. So you can download the sample from which will be like AgentTesla in this video. You can download it from my GitHub page, and the password is you can see the password is infected, or you can download it from hybrid analysis. Brief information: AgentTesla is basically a backdoor. It's a remote access Trojan and stealer. So basically it just grabs your clipboard and passwords and system information and beacons it back to command and control server. If you want to know more information about AgentTesla, you can visit Malpedia. Malpedia is very good resource of information about all kind of malware families. So you can see here are many useful things, many useful links to some information and analysis of AgentTesla. So this reversing will be basically divided into 2 parts. In first part we have to deal with many stages, like exactly 4 stages, where the original payload, original sample will basically during the runtime decode or decrypt and dynamically load another stages and other things, and you have to deal with it, and the next stages are usually obfuscated. So I want to provide a way. I want to basically show you the way how you can patch during the runtime in memory the next stages which are obfuscated, the next obfuscated next stages for the deobfuscated one. So basically you will grab the obfuscated stages, deobfuscate them, and you will in memory patch it. So you will like you will be replacing the obfuscated one for the deobfuscated one. This is basically some tricks for in DnSpy, and I really like it, so I hope you will find it very useful. Other things, basically advanced usage of DnSpy. I will show you how you can benefit from views like call stack, memory view, models view, locals, and other things. Basically, call stack is something many people are not using, and it's very useful. So this, and also during the video, I will show you how you can basically dynamically invoke any kind of method from the original sample from the .NET runtime, and this is basically the dynamic invocation of some method is very useful, because you can invoke any kind of decoding routine, any kind what you want to basically invoke. You can basically replicate the behavior of the original sample from the PowerShell. So we'll be using PowerShell because PowerShell is a very powerful tool which is built in the Windows, and the main advantage of PowerShell is basically it's built on .NET. So using using .NET runtime on something which is built on .NET is very easy, especially in PowerShell. I will also show you how you can manually decode something in Python, but It's basically so only something very not very interesting. So highlights covered in video in this guide on GitHub page. You can see some highlights. Basically, these are highlights which are covered in the video. If you wanna download any script I will be using, any code I will be using from the PowerShell or Python, you can download it from my GitHub page. You can see here I will be using one script. You can download it here. If you click on it, you can see here is the script. You can download it. You don't have to replicate it by your own. Here are many things. You can another script, download it, another script, and some DLL. My own DLL created for for something I want to show you, and other things. Here is part 2. Basically, in part 1 we will get to the final payload. I will show you how the final payload looks like, and in the part 2 video we will be reversing the final payload. Okay, so here are some references, the tools I will be using. So DnSpy, CFF Explorer, Kerber Suite, and for deobfuscation. Also PowerShell and Python, but it's not specified here. And references, good references, information about .NET internals. Basically, here is some introduction for .NET metadata, and here are many useful information. Basically, you will spend like 2 or 3 hours with this, and you will get many information about .NET internals, how basically .NET works. Okay, so we will not waste time, and we will just jump to our VM. Okay, so first of all, here is the original sample you can download from my GitHub page. The link to the GitHub page, to the guide, will be included below this video as always. So first of all, I will start with the Detect It Easy, my favorite tool for detection of protection, and in what language it's written. This portable executable. So you can see that it's a 32-bit portable executable. It should be exe. It's not a DLL, and it's written in .NET. So let's jump back to DnSpy. Okay, put it here. And this. Here it is. And you can see here is the entry point, the main. So basically it's an exe file, so it should have entry point. What is very interesting here, if you right click here, you can basically jump to the entry point. But entry point, the main method here, it's not running, in this case, it's running as a first method. So everything is okay, you just put a breakpoint on the main and continue. But in many cases, something could be defined and it runs before the entry point. And that's something which is called CTOR or CCTOR, CCTOR. Basically, it's a constructor and class constructors. These are things which basically runs before the main. So if, for example, this sample would probably unpack something and load it dynamically in memory, invoke some function. If the something which what is basically unpacked in memory and you are invoking some function, for example, another main, if this next stage assembly has cctor defined, the cctor methods will run before the method you will be invoking. So be careful about that. Just check always if there is some cctor. Okay, but in this case we can jump to the main. You can see here, this is not interesting. You can see my project application runs. So what is application? Application is get return my project. Okay, here's get instance, and you can see my project, it's my application. So it's basically just run instance of this. What is here? This is not interesting, but here are two methods. Basically, these are some kind of default methods, but they are replaced with these defined methods. onCreateMainForm and onCreateSplashScreen are methods which basically runs on the application start. So we first have to check what is onCreateMainForm. You can check it here, create instance on firm enrollments, and you can see here something firm load, and some field box, field list. You can see, check it. So it basically looks like some kind of normal application, and it's very, very usual. You basically, many rats and many backdoors and many kind of malwares written in .NET are basically packed in some normal application, but only some small code is the malicious one. So you can see here not in something, there is nothing interesting, but if you check here what is going on, new VD object enrollment, what is this? And you can see here is the namespace, class, and something something. And I already know that this is very, very interesting string. You can see this is some kind of decimal value in string, so it just got loaded, and here you can see it's trimmed because basically DnSpy don't want to show you all the string, it's very, very long. But you can see that also when the string will be just get, so it will get replaced a characters, the strange a, I don't know how can I pronounce it, but it will get replaced for the value of 377 and space. So this will be replaced with some values. Okay, so for now we know that this strings looks like very, very suspicious. So let's continue. Initialize component, and initialize component, nothing interesting here. Basically like normal application. Okay, so come back, jump back, and jump back. And you can see it was on create main form. But here is another one on create splashscreen, which is again run on application starts. So what is here? Create instance of a when-delay splashscreen and initialize component, and you can see here something. And what is this? What is this? You can see here immediately that two parameters are pushed to this function. These parameters are not used, any of them is used here, so it's suspicious. And you can see here is some function which basically is pushing a parameter here, and the parameter is you can see that is the super strange string. So this string basically just goes to this function game loop, and this game loop O function is doing some decoding. You can see that the string, as I already told you, that the A characters will be replaced with 376, 377, I don't know, you can see it here, 377 and space. So it just, this string just contains decimal string values in one big string. And you can see that this decoding function is doing something like splitting, so it will create an array of decimal strings, and these decimal strings are each one is converted to double and subtracted by 312, and it will convert it to integer and the integer to character, and string builder basically join the characters, so it will create one big string from decoded this object string. And this string, you can see that it goes to here. This is basically just check if the string is not empty, and you can see it goes here, and this string goes here, and this string basically, so you can see from base64 char array, and here is basically the string is converted to char array. I don't know why they just use from base64. Okay, I don't know. Okay, so the result of this like game loop should be base64 formatted or encoded string. It just got decoded here, and after it return it's byte type, and these bytes are loaded, so assembly, system reflection assembly. What I want to do is basically put a breakpoint on the load method of system reflection assembly. This is very good approach when you are reversing any kind of .NET assemblies, because if they are something dynamically decoding and loading, they will be using the basically system reflection assembly. There are many methods. There is not only the load methods. There is a load method, there is load method, a load file, load from file, I think, and other things. But load method is very important here, because nothing is basically nothing is nothing is going to disk, and you are not reading it from disk. Like load file is reading the assembly from the disk, but load enables you to basically load the assembly from the byte array. So put a breakpoint on load, because this will be very interesting breakpoint in the next stages. And what is happening next? You can see the next. This one goes to here, so we just get return the assembly object, and the assembly object goes here. And here you can see that it's getting types, get some type, and this type goes to here. And here is another argument 5, and it's not used. So yeah, okay. So only the type of the assembly which is dynamically loaded. And what you can see is basically something gets called. You can see the method QE in some name, from some class from the dynamic loaded stage 1 module will be dynamically invoked. And here is the invoking function, and you can see here are arguments, and arguments are here. First argument is x2, and another argument, so it's just some kind of array. So these strings goes to the invocation function. And here is some namespace, or some name. You can see this is super interesting string, me_bw. Why? Because if you check resources, you can see that somewhere here is me_bw, and me_bw is some kind of bitmap. So what we know here, that probably the QE function invoked from the stage 1, which will be dynamic load, will be doing some operation on the bitmap resource from the original sample. Probably some decoding, maybe some next stage and other things. So we will check it later. So put a breakpoint here before the invocation of the method QE. And we can start. Okay, start debugging, and we should hit a breakpoint on the load. Yep, we are here. So first of all, just go to debug, Windows, and I want to just show some window which are very useful in debugging. First of all, it's called stack. Another one is modules. Basically, this is window which shows you modules which are loaded in memory. So every module which gets loaded will be shown here, and you can just double click on it and show it in DnSpy and put a breakpoint there and other stuffs. And call stack is very super helpful feature. You can see from where some method is called. You can see, for example, here we are on the load. From where the load was called? From here. You can see here load, and it just got returned here. From where the method A6879 was called? You can see from here. And you can continue like this way. And we will be using the call stack a lot, so I think basically that it's must have no knowledge that using the call stack. Super. So just go to load. We are here. And if in locals you can see something which is already decoded, just will be loaded as an assembly. So just go to call stack, here, locals, and you can see here, as we already noted, that the string here is base64 encoded. So basically the result of the game loop decoding function is base64 string. What we want to do, we can just grab the bytes before they are loaded and analyze it during the debugging. But I want to show you some more different approach how you can do. Basically, I want to jump in the PowerShell and Python, and I will show you how you can basically do this decoding, the game loop decoding and other stuff. So you can basically grab the raw bytes of the stage 1 module, which will be dynamically load. So we can jump to the I already prepared here every script which is here. You can just download from my GitHub repository. You can see here are prepared for the part 1, and there are many of, and I want to show you because these are quite nice tricks. So first of all, I want to show you this one-liner, PowerShell one-liner, view, word wrap. Okay, and yes. So what this one-liner is doing, basically, as I already told you, system function assembly has many methods for effectively loading the assembly, and you can load it from bytes, like load, and put a byte, variable of byte type, and you can also use a method called load file, and you can loading the assembly effectively from the disk. And this is the case. So I'm basically grabbing and loading as an assembly object the original sample. I'm getting type of one delay health benefits and VD object. One delay health benefits is basically namespace, and VD object is class. You can see why. If you check it here, I just want to grab the mapx string value, get value. You can see it here. So the namespace is one delay health benefits, and class is VD objects, and string is mapx. So I'm just grabbing the field mapx using the get type, namespace, class, and get field mapx, get value, and split it with space. Why I'm splitting it? Because if you check the routine of game loop, I'm just doing this. I'm splitting the values to array, and every value in the array I will process the same way. Subtracting 312, I will convert the value to double or to integer. Subtracting 312, you can see it here. I split it. So in this state, where before the pipe, I have the mapx string split it into decimal value strings. And for each decimal value, string value, I'm converting this value to type of integer, because it's a type of string. And I'm subtracting 312 as here, 312. And I'm converting it to character. And I'm basically concatenating it to string. And the string is basically, I'm doing the same as here with the string builder. And the result should be base64 string. So what is next? I basically grab the base64 string, do some from base64 string method, and convert it to bytes. And these bytes I only print 312 bytes. 512 bytes. If I run it, you will see that everything just works. And you will see that we successfully decoded the stage 1 with this kind, something like mixture of dynamic and manual decoding. Because we dynamically get the field of map X, but manually perform the decoding routine. And you can see that it's nicely decoded, the module, which gets loaded as a stage 1. Nice. So this was first method, how we can do it. Another method, which is quite very nice, is doing the same, but only with dynamic invocation here. You can see it here. Basically, the difference is I'm loading again the assembly, and I'm getting type of namespace class and get field map X. So I'm grabbing the string value of the map X, and I'm again getting type on one delay spy screen, because there are methods define the game loop and the A9283 This is the method which basically do the string decoding. We will get the base64 string, and this method will do basically the decoding from base64 to bytes to the module, to the stage 1. So we can basically run it, but there is one problem. You can see that I'm getting get method, and get method just you can search for method and get method which is defined as private. Not in this way. I will show later how you can do it in this way with specifying something different. So what you can do next, you can see here that the game loop method is defined as a private. If you wanna, and the A9283 method, which is here, is again defined as private. So if you try to run it now, what you get? You will get basically that it just can't invoke the methods because they are empty. It just can't find them in this way. So you can do basically that you can patch the flag of this function from private to public. Like right click, you can do it in a DnSpy, and you can do it like edit method, and you can see here the access, and you can check you can basically switch the private access to public, the flag of the method to public. And if you do it also for the function 89283 and save it as a new module, because after you will do these things, you can just go to file and save module. But I don't want to do it this way. I want to show you how you can do it with a nice and really featured tools. So if you want to do it this way, I will show you later how you can do it without patching of the original sample. But in this way, I want to show you, here is the original sample. Now you can run CFF Explorer. Many of you guys probably know the CFF Explorer like a very rich PE viewer and PE editor, but there is also a very neat feature that it can shows you, and not only showing you the .NET metadata if it's a .NET assembly, but it also enables you to modify .NET metadata. So for example, go to tables, go to method, and try to find method which is called game loop. You can see it here. Game loop 0 copy, find, right click, find, and find this method. And you have it here. Game loop here, and you can check the flags. Flags are here, click here, and you can basically edit it directly in the CFF Explorer. Very good feature. You can see it's defined as private, and you can just switch it to public. Okay, and that's it. Do the same for this method, copy it and find it again. Find this method, find, and it's here. Click here, you can see it's defined as private with flag private, and you can switch to public. And okay, now just go to file, save as, and we just save it as original sample patched. Save it. Nice. So now we have this original sample patched, and if you check it in DnSpy, like this, you will see that the methods game loop and the other one are basically already defined as public. Sorry for that. I will just try to find it quickly. Game loop, and you can see it's defined with flag public now because the sample is patched. And another method is the one A9283 defined as public, so it's patched. So we don't need this anymore. Just remove it. Okay, now go back where we are now here. So we have the original sample patched and the methods are already defined as public. Now if you run it, there should be no problem. And that's it. If you check it, we successfully decoded the module. And it's not manually because we just basically invoked the decoding methods from the original assembly. Nice. You can also do it fully manually. I will show you later in Python, but as I'm here, it's not true. It's not true that you have to do it like with the original patching, the original file patching from private to public. You can basically call wherever function or methods which are defined as private also. Here is a little bit proof of concept, it's quite well known, but I created this script and example library. Yeah, you can see mylib DLL. All these scripts and the DLL is downloadable from my GitHub page, so just go to DnSpy and I will show you the mylib assembly. Check it and you can see it's a DLL, no entry point, and you can see here is the class 1, and the class 1 is has one method which basically is print hello. You can see it's defined as private, so you just can't call it by get method with specifying something. I will show you. What is very interesting here again is basically check the original assembly and you can see something that I put here. It's basically attribute for the assembly that disable private reflection. What should this do? Basically this should disable to locate private methods via reflection. So you shouldn't be able to get this method and invoke it. But what just Microsoft says about this disable private reflection? Just I don't know why this basically exists, but check it. And if you check the attribute, the disable private reflection attribute, you can see on Microsoft documentation here is a little remark: the .NET Network, .NET Core, and .NET Framework, .NET Core, and .NET runtimes do not consistently enforce this attribute. Developers should not rely on this attribute to restrict access to an assembly non-public members. So basically, what it just say? It just saying, hey, .NET runtime just shits on these attributes. So basically, you can specify this attribute, but you can still locate and get this method, which is defined as private, even if this attribute is specified via the reflection. So I will show you that it's really possible. So you can see the print hello and other things, but what is different here? Just remove it. You can see the print hello just should write only hello world from private. So just remove it and go back where we are, yep, and jump back. Clear. You can see that I'm loading the DLL and I'm getting the type of mylib class 1, basically namespace and class, and in this class there is defined method print hello, which is private, and also there is the things like even though the attribute which is restricting the access to private methods is specified in the assembly, this is just work. What is different between this and this one is basically you can see that I'm getting method and no other arguments to get method. But here I'm just doing that I'm getting the method and here are some other arguments. What is this system reflection binding flags? You can see that I'm getting method name. You can also get methods via for example method token and other things, but you can see that I'm specifying the system reflection binding flags non-public and instance. what I'm doing with this. Basically, I'm just saying, hey, get me method and search the methods, search all methods for name print hello, and also search specifying the that I'm interested in a non-public method. So basically, search also private methods and other things. So if you have specified the binding flag like non-public, you will search, you will find the print hello method, and you can invoke it. Why in the invoke is this argument is not null? That's because the method print hello is non-static. So basically, you have to specify the class object where the method is defined, and you are doing it like this. And these are arguments. Arguments are null. So specifying the binding flags, you are just saying to get methods, hey, search methods with the assembly which are defined as non-public, so private, and instance. So basically, this is it. You just have to specify the binding flags. And if you run it, okay, the system can blah blah blah. Yep, you can see I have wrong path to the library, so we have to replace it. Just here, copy path, and here again. And what you can see, hello world from private. So we were able to basically invoke, you can basically invoke any kind of function or methods in the assembly. It doesn't matter if it's private or public if you specify the binding flags. And that's it. That was probably all, and I wanted to show you when I jump back that you can also manually decode it with Python, for example. View word wrap. And you can see that I'm using Malduck plugin for base64 decoding, and here is the encoded string. I just copy from the assembly. You can probably deal with a little problem in DnSpy. If you want to see a big string, it's trimmed here. You can see it's basically trimmed. It's not showed all. So you can't just go copy it from here. But if you just go to the edit IL instruction, you can copy it all from the IL view. Just Control A, Control copy, and you can do whatever you want. For example, jump to Sublime, another editor, and you can just paste it. View word wrap, and you can see that the string is full. Yep, no trimming. So if you can copy it from the C# source code view, you can just do it from the IL. Okay, and you can see here that I basically re-implemented the decoding procedure. You can see that I'm just taking the encoded, and I'm just doing the replace the encoded the A characters with 377 and space, split it with space, and for each this string decimal value, convert this string to integer, subtract 312, convert it to char, and concatenate to string. And this base64 string just gets decoded and print first 200 characters, or bytes, in this case bytes. And you will see that basically we were able to successfully decode it manually, fully manually in Python, the stage 1 module. And that's all. That's all. So basically I want to show you how you can do it dynamically from PowerShell, fully dynamically via invoking the function in the right order as the assembly is doing, as the original sample is doing, and how you can do it like semi-manually in one-liner, PowerShell one-liner, how you can do it via the invocation but without patching the original assembly. So it's possible if you specify the binding flags, and how you can do it in Python. And that's all what I wanted to show you, like quite nice tricks. And we just come back here and we just can jump to load. We are in the load. You can see that this stage will be loaded, so you can right click and save it as stage 1 from the memory. go to downloads, directory downloads, and we can save it as a stage1.bin. Save it. Don't continue because we want to replace it, because if it's obfuscated, we want to replace it for the deobfuscated one. So let's jump back to downloads. And you can see that stage 1 is again .NET, and it should not be deobfuscated, but we will see later. So let's run another instance, DnSpy. You can see that it's a 32-bit. So let's just throw it to 32-bit. It doesn't matter if we are not debugging it, but you can see it here, and it's some kind of DLL, beautiful UI, DLL, no entry point, and if you check it, it's obfuscated. But what I really don't like, it's probably some kind of a custom obfuscator or something like that. In many cases, you just can use some known deobfuscator, but you can Google it if you know what obfuscator was used. But you can see that this is something what really bothered me a lot. I want to have the arguments to the methods or parameters to the methods to be some kind of nicely named. So we can do a little bit cleanup with the deobfuscation tool called d4dot. So let's close all and just run the d4dot. Let's find it. These are my repo, malware analysis tools. And here is the obfuscators, .NET deobfuscator, and d4dot. d4dot is here. Here you can see the stage 1, and we will do some little cleanup. Stage 1 and d4dot. Unknown obfuscator, but it will do some cleanup for us. So let's put it to DnSpy again, the cleanup one, and you can see here that already we have something. At least rename the arguments, yeah, the parameters to the methods. So this will be very helpful to follow the arguments and other things. Nice. So what we want to do is basically replace this stage 1 cleaned for the original stage 1. We can see that we are on the breakpoint where the bytes of the original stage 1 will be loaded as an assembly. So we have to replace it in memory somehow. I will show you how. So first of all, just run, for example, cyberchef. So we will be replacing it in memory, but we have to replace it in some kind of format. So just drag and drop the stage 1 clean here and convert it to hex and no spaces, like this. Copy raw output to clipboard. Nice. And you can see that the original sample size, the original stage 1, is larger than the clean one. That's good, because you can see that this clean one size is C000, and you can see here is the size already of the byte which will be loaded. It's D200, so it's larger than the clean. So no problem, we just replace it in memory and there will be more space, basically something like overlay of the original stage 1. But if the byte will be like, if the memory allocated for the stage 1 will be smaller, you should find some different location where you should replace it. For example, you can go to call stack and you just want, for example, go here and replace it in here. So you just for example, you want to replace here the string, and you just replace the string here in the memory and everything is okay. So if you want to do it in this way, just grab the clean one here and convert it to base64 and replace it here. But in this case, and in many cases, the clean one sample will be smaller. Yeah, the clean one will be smaller than the original one. Okay, so just come back to the load locals and go to memory view. show in memory view, and you can see that we can see here is the original stage 1, which get loaded as an assembly effectively. So what you can do, we just copy to clipboard this, the clean one, and right click, paste, and paste. Yep. And you just override the original stage 1 with the clean one. You can see here is some overlay from the original one, but we just don't have to bother with it. It just got trimmed, and our clean will be loaded. So we can continue. Okay, we just hit the breakpoint before the invocation of the method QE. And if you check the modules, it will be already loaded. You can see Beautiful UI. If you double click on it, you have it here on DnSpy. And yep, it should be, you can see that the module which is loaded is our clean. Yes. So go to call stack again, go to the function where you are now, and here you can see will be performed the invocation. So what method will be invoked and in what namespace and what class? You can see here basically full name tfdr and method which will be invoked QE. tfdr. So just go to the Beautiful and go to tf. TF is here, namespace, FDR is here, and you can see QE. Okay, as you can see, the DR is here, so namespace is TF, and class is DR. And here is the method QE, which will be dynamically invoked. So put a breakpoint here on the start. And let's just check again if there is another CTOR. There is no CTOR, so okay. Continue. And we are on the QE method. What is happening here? You can see that it's good that we have already this nicely renamed and cleaned with the d4 dot and replaced the in memory the clean one, stage 1. But what is happening? You can see the arguments pushed to the method. As we already mentioned, there is me_bw. It's basically the bitmap resource of the original sample. There is some string probably used for the decryption of the bitmap, and the namespace or the name where the bitmap is presented. So there are many things to cover, but you can see that this function is not so large. So even though it's still some kind of obfuscated, it will be very, very easy. So we will put some breakpoints here on the interesting location. For example, for me, first method is this one. Case, I will put a breakpoint on the cases. And we will check what we hit. And it's probably, oh, yes. So if we check it, this method QE, we can see that it will probably work with the bitmap, probably the me_bw. It will probably create the assembly object from the bitmap after the decoding, and the assembly object will be probably dynamic load, and there will be invocation of some other function. So probably some kind of the next stage. So we can continue. And we hit breakpoint on the first method, which will be called. You can just jump to the method, and it's super strange. And it's super strange because you can't see basically what is happening here. So if you check it, you can see that something is invoked here. I8, and you can see that I8 is basically doing some, there is some method, and what it just do? It just use the resource, some kind of resource, and it will do it, it will perform some kind of decoding. Basically, according to this decoding, it just decide what function which will be dynamically resolved. It will just push some arguments to this function and create this function. So this is some kind of dynamic resolving of the function which will be dynamically invoked. So if we put a breakpoint here, we just should hit it, and the function which will be invoked should be already resolved. So you can see here is the object I8, and you can see the method sleep will be invoked. So there will be sleeping, and here is the argument. We can check it in decimal, so it will be sleep like 25 seconds. So we don't want to sleep it, we just want to continue. Just patch it and continue. F10, like step over, and you can see that we just didn't sleep. And just continue. We hit another breakpoint. You can see the return value for this method is bitmap object. So basically, you can see the string 0 is the bitmap resource name from the original sample, and string 2 is the name where basically this resource is located. So this method should be something which manipulates with the resources and retrieve the me.bw resource, and if you check it, yep, it's just manipulating with the resources, and return value is bitmap. So okay, bitmap. Let's continue. What's happened next? You can see the bitmap object, which is already created, and a me.bw bitmap is already populated, is passed to this function, and the result is some bytes, so probably some decoding routines of the pixels. We can see, yep, here is the color, so RGB, probably some decoding of the pixels, and it will retrieve some bytes. If you press F10, like step over, you can see that what you can see in the locals window. First one is the return value of the method. If you step into the method and just go through the method and return, there will be no this return value in the locals view. So step over is very, very useful. You can see the returns bytes. Just click on it, yes, and you can see that there are some bytes, but it's not still some kind of PE file or module which could be loaded as an assembly. So let's continue. We can see another method right below this bitmap operation, and it just grabs the byte, these bytes, and what it does, it just gets the string 1, and it will be performing probably some decryption or decoding these bytes. So let's check it. Yeah, many things, but you can see here is some decryption, XORing, and other things. I don't want to deal with it, so step over it, F10, and you can see again return value from the DRTF, the TF method, and if you check the bytes, there are still some kind of bytes, and it's still not some PE file, some module which could be loaded as an assembly. So just continue. And you can see that basically these bytes are pushed to some method which resolve in some other byte variable. And I think that this should be some kind of a decoding decoding method. And you can see that, yep, it just create memory stream and gzip decompression, maybe some manipulation. So these bytes are some kind of encoded, and after decoding, it just get decompressed the gzip, and the return should be, you can see the return should be some bytes. Okay, so step over. And we just here have the another bytes, and you can see it's already the PE file, the module which will be dynamically loaded as an assembly. Well, you can basically save it from here, but we will continue and we will check what is going next because we can grab it later. Continue, and you can see here that the byte2 object goes here, and what is going on? You can see the return value of this method is some kind of assembly. So these bytes, the PE file, should be effectively loaded as an assembly to this object. And you can see here again some dynamic resolving of the function. If you put a breakpoint here, continue, you can see that DDO object is basically resolve method of system reflection assembly load. Nice, so this object will be loaded. We can just continue because if you remember, we have already set breakpoint on the load method. And you can see here is the stage 2, I think. Okay, stage 2. So we can just grab it, save, and save it as a stage2.bin. Stage2.bin. And now I want to check this stage 2. If it's some kind of obfuscated, we can deobfuscate it and other things. It's all again .NET 32-bit stage 2, and you can see, oh my god, it's obfuscated. And I don't want to deal it with this. I want to do some cleanup, at least some cleanup of this. This is basically, I think that Unicode encoded some Unicode encoded strings of the methods and other things. So I don't want this is basically something d4 should clean very easily. So we can just close it, close all, and just use the d4 for this stage 2. Stage 2. And you can see detect unknown obfuscator, but renaming and doing some cleaning. And if you check it again, the stage 2 cleaned, you can see that we can nicely see the main, and it's more readable, far more readable. But remember what I said, main is basically some function which is invoked as main, as an endpoint, but there is something what is called before entry point, something like ctor and cctor, the constructors. We can check if this assembly has a constructor, and you can see here the option go to module cctor. Where you can see it is just here, module and cctor. But if you jump here, go to module cctor, these are methods which basically runs before the main, So be careful and put a breakpoint here after we replace it in the memory and other things. So, okay, now we have many informations. New file, close all, and what we want to do next, you can guess, just basically what we already did, replace it in memory. We want to replace the obfuscated one for the deobfuscated one. In this case, it will be very helpful. Check it here, and again we have it here, just copy raw output and go to DnSpy. We are here, right click, show in memory window, memory 1. You can see here is the assembly, and right click and paste, special paste, and we replace it. There is again some overlay, but we just don't care about it. Nice. Now we can continue because we have another breakpoint here. If you check the modules, it's already loaded. You can see it here. Just double click on it, just go here, and what you should, we will deal with it later. But now just come back where we are, go to locals, and you can see some other methods is invoked here. Again, dynamically resolved, so just put a breakpoint here, continue, and you can see that what will be performed here. Call by name, and call by name entry point. It just basically resolved and gets you the entry point method, which is defined in the stage 2, which is the basically main. So just continue. Continue, and we hit the last breakpoint, and you can see there should be some. You can see here the object is defined as the main method. So basically this function, or the function which basically invoke the entry point method, it just gets the entry point method name. So it's the main method which will be invoked. You can see here another method, object, go to object 3, and object 3 is pushed to this function. Just put a breakpoint here. We have it here, continue, and we hit it again, but you can see that again, call by name. But in this case, we will be calling the invoke. We will be invoking the main function of the stage 3 module, stage 2. Yeah, so here is the main. So put a breakpoint here. But be careful, as I already point to you. Here is the cctor, class constructor. So put a breakpoint here, and I will show you that the cctor will be running before the main entry point. Just continue, and you can see that we just hit our cctor. Okay, so what is here happening? We can put a breakpoint on this method and on this method. First of all, there is some first function, method 15, and you can see method 15 creating some big array. Wow, that's so large. And we want to see some methods which is processing this array. Oh, I skipped. Nice, here. Go. And you can see basically here is one method, assembly resolve. We are not interested in this, but there is another one method which just basically load it. So this will perform some decoding of the byte array, the big one, and you can see that it will just get loaded as an assembly. So stage 3, just put a breakpoint here and continue. We hit the breakpoint here, yep. And if you remember, we already set breakpoint on the load assembly, like system reflection assembly load method. So we can just step over it. No, we can just continue. Continue, and we hit it breakpoint. And we can see here is the stage 3. Save it, and stage 3.bin. Save it, and let's check what is this file. It's again .NET assembly, so it just gets loaded. And if we check it in DnSpy, we will be quite surprised because it's a DLL, but there are no methods. There are no methods defined, so basically it just get loaded, and probably no invocation will be because there are no methods here. So you can just think that there will be something interesting in this module. And what it is? Resources. And resources there are plenty of, but you can see many kind of interesting bitmaps. Probably the stage 2 will be doing some manipulation of these resources, decoding, probably stage 4 or the final payload. You can see also this kind of strange resource. It should be here, XML file. So you can see this, it's kind of XML configuration file, and you can see it's task version 1.2. I'm quite familiar with this kind of format, but if you see it something like for the first time, it's basically XML configuration file for the scheduled task. So probably some configuration file for the persistence. Okay, but we are not interested in this file. It just gets loaded, and nothing interesting, nothing to deobfuscate, and nothing what will be invoked. So we can just continue. And we will hit another breakpoint in the CC_TOR. And we can see method 9, and what is happening in method 9. Again, some big array. Just scroll a little down, and you can see here are method. This is a method 8, which will do something with the array. And there are many cases, but no other method. So we just can continue to hit the breakpoint. And you can see we hit the breakpoint, and if you want to it just perform the method 8 with the array, and the returns value, the byte goes to this field of type byte. So we can press F10, like step over, and we should have here the return value, these bytes. If you check it in memory, show in memory, and you can see it's kind of super interesting strings. Okay, so just go here, right click, save it, and save it as some kind of decoded strings.bin. Okay, and continue. We hit the last breakpoint on the in the CC_TOR, and you can see the stage, the decoded strings. We can just check it in 101 editor, hex editor, and you can see these are strings, which are super interesting. But you can see that the string is defined like, hey, 5 character strings preceded with the length of the string. You can see here is the 16 length of string, and it's preceded with the 16. You can see here is the 4 bytes and preceded with the length. So I want to see only the strings, so you can do it quite easily way in 101 and find strings, length 4, ASCII and Unicode, find, just go here, right click, copy column, and go to here and paste it. And you can see here are the strings. There are many very well-known strings like sandbox DLL, so and typical names in the sandbox. So this will be probably some sandbox evasion strings related things, but here is also anti-VM related strings like virtualbox, checking if guest editions, and VMware tools. and other things. Okay, this is not interesting at all, but we can scroll a little down if we see something what is next here. You can see here oh, Windows Defender, so AV evasion, so it will probably set the Microsoft preference, disable real-time monitoring and everything, so disabling the antivirus defender, Windows Defender. And you can see also scheduled tasks, so maybe some strings related to creating the scheduled task. We already saw the XML configuration file for scheduled task, and you can see typical names of executable which are used for injection. Maybe they are used, I don't know. This is basically I think this is basically configuration file for the red, for the AgentTesla, and according to this basically some kind of string, these things will be performed. Nice. So we are not interested in that, and we can just continue. We are in the last method, and this last method is performing a lot of things, but basically you can right click, analyze it, and you will see what this method is uses, and you can see virtual protect and many things like get type from handle, get module, and something. Nothing many interesting things. Maybe it will be performing because virtual protect is used for changing the protection to be executable, for example, to some memory. And you can see here is the copying and other things, so it will be probably replacing something in the original in this process. We are not interested in that because you can see there is nothing different, just changing the protection and copying some bytes. So if something gets changed, we will see it in DnSpy, just get refreshed. So we can continue to hit the main method, and we are on the main, on the entry point of the stage 2. We just throw away the stage 3 because it was just the module. You can see the modules here. It's this module which is just basically still no methods here, only the resources. Only the resources I already showed you. So come back again. You can just use call stack and go to main. And what is going here? You can see the main is quite large. Many methods are invoked here, from here, or called, and we just don't know what these methods are doing, and they could recursively call another methods, and it's never ending story. So what we will be using? We will be using the analyzer again. So just remove this to really quite a fastly way know what is going on in the main. So analyze the main and check it here. What it uses? Method 10. It uses just only some create instance, block copy, and nothing interesting many. So method 10. Method 13 uses, and basically almost the same as method 10. Another methods, method 0 uses, and you can see that it uses method 11 uses and just message box. Okay, method 1 uses, method 12 uses open existing mutex. So it just something about mutexes, maybe to checking if there's yap and app. If the instance is already running, it just exit itself. And okay, so this is about mutexes. Method 4 uses, oh, so many things happened here. Method 4 uses, oh, okay, string replace, get temp file. Okay, but I'm not interested in this. I already know that the most interesting is I think method 9, but I want to show you the approach how you can find what is interesting here in the fast way, like uses and again system recursion method based invoking something and other things. But if you check method 9, this is very interesting one. There is method 10 and method 6. Method 10 is just using many things. Yep. You can check what these are for and other things, but most of them is just garbage. And you can see method 9 is using method 6, and method 6 uses method 7, and method 7 uses and check it. This is super interesting because what you can see here: create process, get thread context, unmap view of section, reads process memory, resume thread, set thread context. There should be some write process memory, virtual alloc x, write process memory. So basically this is P injection. It will just create, you can see the virtual alloc x search for the allocated memory in the remote process, and write process memory again for the writing to the remote process. And this is basically, if you check the Windows API, which will get called, you can immediately see and say, hey, it's P injection, and in this case, it's a process following method. So that's correct. What we can do now, if we can confirm it quite fastly, you can do something like I will show you later. So for now we can see that our interest is method 7. Just go to the method 7. We are here, jump to the method 7 and locals method 7, and you can see here the create process is interesting one, first one. Continue, and we hit the process creation. So you can see here are the methods. Virtual alloc x, we already see that method 7 is using these methods, read process memory and other things like virtual write process memory. Virtual alloc x should be somewhere here. Okay, many things. And get thread context, resume thread, and unmap view of section, set thread context, and other things. So I'm very interested in, we can analyze the method 7, or we can just other things. What you can do is basically just scroll in the main, like if we were in the main function here in the main, you can just check it around. If there is something interesting here, you can see, and you can see it here. They are basically define the Windows API methods which get called, and this is basically already process injection, P injection. So you can just basically, for example, I'm interested in the resume thread because I want to put a breakpoint here, and I want to analyze it, and I want to see used by. Searching used by. Okay, it just maybe some bug in the DnSpy. Okay, so what we can do, we can basically copy the string, Control F, and find the string where it's used. Here it's used, and here. So I put a breakpoint here, and you can see that we are here in the method 7. Method 7. Yep, method 7. So we have put the breakpoint on the create process and the resume thread. In the create process, you can see here are the some arguments. String 9, you can see, is the application name. It's basically the same name as our original sample, so it will create new process with the same name, and probably in a suspended state. You can see the method create process. If you check the Microsoft documentation, like here, Microsoft documentation, arguments, the 6th argument should be the creation flags. 1, 2, 3, 4, 5, 6 creation flags. If you check the creation flags, you can see here the sixth argument is 1, 2, 3, 4, 5, 6, 4. So it's a value of 4. And if you just see the creation flags, you can see the value 4. Value 4 states for create suspended. So it basically creates the process in suspended state as we expected, and it will perform the process hollowing. So we can continue. We hit the breakpoint on the resume thread. So basically now we can confirm that new process is created. You check the process hacker. You can check, here is the new process. This is the first one, and this is this one which is in suspended state. You can see the gray color. And you can see, I will show you here, you can see that it this is very, very interesting, because in option you can highlight executable pages, and if you check the memory, you can see here are the memory which are executable marked protection memory, which basically direct to some module. These are not interesting. This is not interesting, but this is interesting. Read, write, execute module protection, and no module associated with this memory. So, and the base address is 40000. So it's basically very, very interesting. If you check the memory in process hacker, you can see it's the last payload or last stage module, the AgentTesla, which got injected to this new process, and it will get run with the resume thread. What we can do here is basically we can just, for example, take the memory and save it from process hacker, like save memory, and be careful, because this is already virtually mapped. You can see the big spaces between the section B header and other file. Other things. So you should, after the dumping it, you should repair it with tools like p-unmapper from HasherRes8. Another approach is to try to locate the raw bytes in some locals in DnSpy. If you check it, just check the arguments which goes to the method 7. Method 6, just method 7, and method 7, check the arguments. String 9 is the application name, which resolve in the new created process, and here is another argument, byte 1. And byte 1, if you check the byte 1, it's p file. Is the module which basically the assembly which gets which will be injected to the new spawn process, and it's in format of raw bytes, so not virtually mapped here. So you can do just save it, and you can save it as a final payload.bin. Save it, and now you can basically continue. Let's continue. And it's finished. The original just exited, and you can see here is running the suspended, the final payload which is injected in this process. If you check the modules and memory, you can see here again, this is the AgentTesla payload we already dumped from the DnSpy in a raw format, not virtually mapped. And if you check the modules, there is something in a process hacker which is phenomenal. It's called image coherency. You can see image coherency of the modules. What it means, image coherency is basically difference between the module which is on the disk, between the executable file on the disk, and between the exe file which is virtually mapped in the process space. So basically there shouldn't be much difference. You can see the image coherency 100% is basically exactly the same. The module on the disk is the same as the virtually mapped. Here you can see that on the base address on the virtual address 40000 is something which has a file name on the disk here, and the image coherency is 0%. So it's absolutely different to the disk executable, and that's correct. That's basically the injected PE file. And if you check in memory, it's basically our interesting memory, read, write, execute. So you can basically find the process some kind of code injection via the image coherence in the process hacker. Very, very useful feature. Now you can basically end it, terminate it, and we can just close all of these because we just finished our first part, and we just can check the final payload. It should be .NET. It's .NET application. You can see it detected the obfuscator, the obfuscator. Obfuscator, I think it's a open source obfuscator, .NET obfuscator, and you should maybe be able to find open source deobfuscator for this, but many of them just doesn't work. So I will show you here. This is quite a simple obfuscator because you can see if we go to entry point, you can see it's obfuscated, but mainly the strings are obfuscated. And the strings are obfuscated in a very, very nice and strange way. You can see it like here, if you jump to the obfuscation, you can see that basically there is class. There is there is namespace and there is class, which basically is only for the string deobfuscation. And here, so basically the string deobfuscation routines is divided into all kind of methods, which when it gets called, it resolves one string and replace the value in the original method from where it gets called. So some kind of quite strange obfuscation, but I will show you in the second part of the video how we can deal with this kind of obfuscation and how we can grab the and have nice readable code of the AgentTesla payload. But this will be a part of the second video, and I hope you will join it. And that's all. I hope you enjoy this video, and I hope you learn some new things. I hope you find it quite interesting, and see you on the next part, which is already which will be very, very soon available on my YouTube. Thank you for watching, and see you next time.